I'm Lawrence Schwedler. I'm the Director of the Music and Sound Design Programs here at the Digipen Institute of Technology. And I'd like to introduce our speaker tonight. Max Hayes is an audio engine programmer at Epic Games, right here in Bellevue, where he contributes to core audio engine technologies in the Unreal Engine. And I'm going to assume that most of you know what that is. If you don't, you will know soon. It's a big, big deal in the big move to real time that all, not just the entertainment industry, but the architecture industry, the automobile industry, the film industry are all moving towards. Max works on technologies including caching systems, ambisonics decoding, meta sounds, which maybe he'll talk about a little bit tonight, or no, not so much, not tonight. Digital signal processing optimizations, and the Quartz scheduling system, which he will talk about tonight. Just a bit of background, Max studied music production and sound design at Berklee College of Music before transferring to Digipen, where he graduated with a degree in computer science and digital audio. Along the way, Max worked as a front-of-house mix engineer, freelance indie film composer, and teacher of guitar performance and music production. And through these experiences, Max has acquired a deep appreciation of the creative and the technical aspects of audio, which he now applies to his work at Epic Games. Please join me in welcoming Max Hayes.
Thank you very much. Thank you, Schwedler. So I'm Max Hayes, and this is my talk on Quartz, audio and visual sync for procedural and interactive systems, which is a serious sounding way of how do we have video games where we don't know what the player is going to do and have strongly timed audio and visual effects to go along with it. This is basically what Schwedler just said. Okay, so our agenda for tonight. So I want to do a quick overview of what game engines and audio engines are. How many people are audio professionals or audio enthusiasts in some way? Most. How many people have worked in video games? Specifically, quite a bit. Okay, killer. How many people have heard of or used Quartz before? Okay, some of you might be lying, but that's cool. Awesome. So we're going to talk about our core goal here, which is I want to be able to do stuff perfectly on beat. I want to play sounds on strongly timed boundaries, and I want that to be in sync with the visuals. And then we're going to talk about the problems. I don't seem to be able to do stuff perfectly on beat, and we'll dive into the nuanced reasons why, multi-threading, latency and all this kind of stuff. And we'll talk about Quartz as a solution, what it's actually doing under the hood to solve these problems. And I'll show a little bit of what some demos and what people are doing out in the wild once you have something like this, what it actually unlocks for you. So this is Unreal Engine. I downloaded it, not from our internal code, but this is the release version of Unreal 5.4. And I opened up a new project. So this is one of the first things you can see. When you create a new project, you can create a project from a couple different templates. This is the first person template. And I haven't done anything yet. So this, you'll see me, I've been told to mute my mic while videos are playing. So I'll try to give you a preamble of what you'll see for each video. But this one, you see, you can pick up the gun, you can shoot a ball out of it, and it makes a noise when you shoot the ball. And there's physics interactions when the balls hit these blue cubes. So that's a video game, we'll call it. So to make this talk, I then spent maybe 2 or 3 hours taking that project and just doing a bunch of Quartz to it, just to give you an idea of what our end goal here. And I'm not a visual effects artist, but you should kind of see what we're talking about. So lots going on. We had things moving to the beat, things turning on and off to the beat. The sound, all the weapon fire and stuff like that was at different musical durations. Yes.
Hello? There we go. Just real quick, only because this has happened to me in these presentations before. In case anybody who was watching that thought that that was a pre-rendered video, yes, it was, but there was no sweetening. That's what it sounds like when you're actually playing the game, okay? And I know a lot of you haven't worked in video games perhaps, but if you have, you can't do that. You can't do that. So all of that precise timing of picture sound, that's what the whole deal is. And in case you missed it, it's a bigger deal than you might think. So just had to say.
Sure, no, thank you. Yeah, and that's just me recording my screen OBS. I'm in control with a little controller, choosing when to shoot, choosing what musical duration to play. We have another question? Oh, that's for him. Private meeting. Okay. So we'll work our way up to it. So what is a game engine, especially the sound part? And this is important to our discussion, especially if you're not familiar with games. A lot of you are, so this might be review, but it's useful as we build up to what Quartz is actually doing. So a game engine is simply a collection of real-time software systems working in concert to create a dynamic user-driven experience. And in this room, audio gets to be the big bubble because of where we are, but you also got graphics as part of it, animation, physics. So all these things are working together to make an experience that the player is in charge of. So we have this. So that's what I mean by dynamic. It's not the same every time, like versus film, which is very linear. You know what's going to happen. You could do all that to Schwedler's point beforehand. It's dynamic. It's not going to be the same every time, and it's user-driven, meaning you don't know what your player is going to do. You don't know when the player is going to decide to jump, when to fire their weapon. So all these systems need to work together to provide an experience that somebody else, your audience, is in control over in real time. So we have this thing that we'll talk about called the game loop. So an analogy I like to use is thinking of a game engine or game kind of as a computer running claymation. So we have to get a frame to the screen every 60 times a second, 30 times a second, maybe hundreds of times a second. And so we're doing this stuff over and over again in a tight loop. Maybe at the top of the loop, we check for input, what buttons were pressed, what's the player action? Are they jumping? Are they pausing? Are they quitting our game because they hate it? And we'll use that information to then update all these systems like physics. Maybe something's falling and in this tiny 30th of a second, it's gone from here to here, right? All these tiny little updates to everything. Animations, the player's walking and so their left foot went from a foot from their leg to 13 inches from their other foot. All these tiny steps forward, like a claymation thing. And we update all that state, and then we draw that to the screen. And we're doing that over and over and over and over again. All right, so that's our game loop. That's our game thread. So then what's an audio engine? In some ways, it's an engine within a game engine. In other ways, it's an engine alongside of a game engine. But it is also a collection of features that sound designers use to create dynamic sonic experiences for the player. So we have things like maybe we have synthesizers running, generating source audio, or we're streaming from disk, and we have to run decoders to get our source audio, right? We have voice management. What do we do when too many sounds are trying to play? Do we stop the oldest sound? Do we ignore the new request, right? We have mixing, which is super important. Dynamic music system, all kinds of things working together too. If this is the loop that's deciding what's going to come out of our screen, right? The audio engine, this is the loop that's deciding what comes out of our speakers, right? And these things are working together. So at the top of our audio engine update, we're starting sounds, we're stopping sounds, we're running these decoders, getting our hands on source audio, and then we are running all these things through our submix graph. Maybe we're running analyzers for visual effects. Maybe we have submix effects like reverbs, things like that, and then we're going to mix down to a final buffer so that data can be sent to the operating system so that it can actually come out of our sound card. So games are inherently multi-threaded, and that's a bit of what we'll be talking about. So audio basically always has its own thread. So there's this thread where the operating system is periodically tapping our application on the shoulder and saying, hey, got any more of those audio samples? We're about to run out. We need to get some more stuff to the speakers. And then our game logic is going to be running on the game thread. And these two things need to talk to each other back and forth. And that's a big thing that Quartz solves. And even this is a slight oversimplification for both for Unreal and probably a lot of real-time applications, even like a DAW Like, for example, Unreal also has an audio thread that is parsing all these game thread commands about playing sounds and deciding if that sound's actually going to make it based on what other sounds are playing. And then we're also doing our rendering on its own dedicated thread that is not what the operating system is talking to us on. So there's actually like 4 threads, but for our purposes today, it's fine to think about the game thread, which is drawing things to the screen, and which is deciding when to play a sound, and an audio thread, which is getting those events from the game engine, from the game thread, and rendering it. So it looks a little bit like this. These 2 big players here, these 2 big threads are running in concert all the time. This is doing its thing. The game loop is going 60 times a second to draw things to a screen, and the audio engine is doing its thing. And so these are talking to each other by staging commands. So the game, we might have an update where it says, ooh, you know, something bounced off of something else, we're going to play a sound, and that'll get sent to the audio engine, and the next time it updates, it says, gotcha, bro, I will make that come out of the speakers. Any questions about that so far, that hand-wavy generalization of game engines? Cool. So let's see some work done in a game engine. So in this video, I just have a little actor here that I've made. It's just a cylinder. It's got some text on it. It'll play a sound when you run into it, and when the sound is playing, it'll be orange instead of white. Play. So pretty straightforward, and this is what it looks like to make one of these. So it's hard to see up here in the top left, but this actor has some components on it. It's got a text component, which, as we can see here, the default text is sound name here. It's got a cylinder, so it has some geometry we can see. It's got an audio component, so it can actually make sound. And this is our logic. So a lot of our examples will be in this. This is called Blueprint, and it is Unreal's visual scripting language. And this is where, in like our claymation example, this is where our little per frame updates are happening. And this is, among other things, where we will decide to play sounds. So at the top here, we have event begin play. That stream of logic just runs once when the game starts. So in this case, we're setting up a sound. You can see set sound call. Those are functions. And the white lines here are flows of execution. So all we do at the very beginning, we do it once. We set up our sound. We grab the audio that we want to play. And then we set the text to be whatever the name of the sound is. And you don't have to understand this too deeply, but just we're doing this and then we're doing this, right? Grab the sound, grab the name of it, and then set the text to show whatever sound we decided to play on that actor. And then down here, we get an event from the physics engine saying, you got hit by something, and we'll take that opportunity to play our sound. And then this is not very efficient, but I wanted to do something on tick. So every frame, I'm saying, hey, is our sound playing? If it is, we're going to set the material to one thing. If it isn't, we're going to set the material to something else. So this is what makes it our cylinder orange when the sound is playing and gray when it's not playing. So we can see this actually in action here. You can see the execution live in the blueprint when I'm running this little example in editor, and added some voice acting here to be a little bit more immersive. Ouch, also. Oh, ouch, also. Ouch. Ouch, also. No, thank you. Oh, ouch, also. No, thank you. Ouch, also. So you can see when we get hit, we can see this executing, and you can see this running all the time. It's true when the sound's playing, and false when it's not playing. So this is kind of our sandbox for the evening. This is where we're going to be hanging out. So how do people feel about this blueprint running a bunch of times? Right, great. Cool. And so you're saying, okay, I think I have a pretty good handle of game audio now after your last 6 slides. So as a sound designer, I want to be able to play sounds on strongly timed boundaries, right? We're trying to get back to that initial example I had. Could be dynamic music, right? It could be a machine gun that's going super fast. Anything that's lots of things that are strongly timed. Or maybe you just want the convenience of a music system. You want to be able to think of things as a tempo-driven system, like breathing systems, heartbeat systems. And I also want to be able to trigger gameplay logic and VFX in sync with audio, which we were kind of doing before, but it wasn't on any type of musical grid, right? It was just when physics said we bumped into the thing, we played the sound, right? So why wouldn't this work by default? Like if I'm getting all these updates, all the time, why can't I just do a little math? Yeah, okay, I'm running at 100 beats per minute. I can do some math to figure out how many milliseconds a quarter note is, and I can decide if it's time to play my sound or not. So let's try it. So here's a little system that is going to take, we get a notification when a bar happens, when a beat happens, and when a 16th note happens. So those will fire just like our other logic. And then when we get notified about a bar, we're going to play a high click sound. This is just a normal play call that we've been using so far. This is not Quartz yet. And when we get a beat, we're going to play a low click sound. And every 16th note, we're going to play this little noise burst like hi-hat type thing. So this is running at 99 beats per minute. Let's check it out. So how do people like that? Any drummers in here? Not good? Yeah, so the technical term for that is sucks. So not quite my tempo. That's not what I was looking for. And that's even, I'm cheating a little bit. I'm actually using Quartz to tell me about the musical durations. So this is best case scenario, but I'm using this normal play call. So to drive this home a little bit, this next example here, we're gonna start using Quartz. I'm gonna jump ahead and use this new call, play quantized, that we see. Might be a little small, but these three boxes on the right next to our little video screen there. These are now using a call that Quartz brings to the table, so we can play these sounds on a grid. So our bar and our beat are both going to be accurate because it's using Quartz. And our 16th note is not going to swap back and forth between just a normal play call and a play quantized call. Nothing else is happening. The game is still being notified about the 16th note at the same time. And you'll see the difference here. When the execution pin, when this lights up orange and it's going down here, that's a normal play call. And it'll say without Quartz up here. And then it'll flip back and forth between that and play quantized, and it'll say with Quartz, and it should feel pretty locked in. Oh, you feel the difference there? It almost feels like it wants to swing, but it's even then it's not consistent. It's brutal. And one more dose of torture, same thing, but with 30-second notes, so we can really drive the point home. So pretty brutal. So the first obstacle here is that the game thread only ticks at a limited rate. Like we've talked about, this game loop is running at 30 times a second, 60 times a second, maybe even a few hundred times a second. But those are our only opportunities to actually decide whether to play a sound or not. So that's pretty rough. So we're going to see this timeline a lot throughout the presentation. So at 30 FPS, the game's only going to update every 33.3, repeating, of course, milliseconds. So this is our game loop from earlier, right? So this is every vertical line here represents one video frame of the game, right? So this is that game loop unrolled, running at 30 times a second. Does everybody feel okay with this visual? Because I'm going to lean on it pretty heavy. Okay, this is what a 16th note looks like at 120 BPM compared to our frame rate, right? And then we have our audio render thread here, which we're throwing commands to. So this is rough, because even though a 16th note at 30 FPS is a pretty large duration event, but onsets start in between our gameplay frames. So somewhere in here is our little blueprint's chance to say, hey, I want to play a sound, or I don't want to play a sound. So we're here. Frames 1, we'll try to play 1. 2 and 3 will say not yet. 4 will still say not yet. 5 will say, shoot, should have played one a third of a frame ago. So we'll try to tell the audio render thread to play something. And then same issue down there. So this grid is not great. We need to find a way maybe to be allowed to decide to play a sound closer to when a 16th note is supposed to occur. So we're gonna have to add to our wish list here, not be bound to the game's frame rate, right? I need to be able to trigger sounds between game frames. That's part of our problem. But if we just figure that out, then we should be golden. Like audio is very high res, right? We talk about sample rates is 44,000 kilohertz, 48,000 kilohertz. So if I can get the game to let me make a request at the right time and it lands on an audio sample, I should be pretty close because it's super high res. But as a lot of you probably know, audio is not rendered in samples, right? It's rendered in buffers. If you're used to on your DAW being able to choose the buffer size, right? If there's some order magnitude, some power of 2, 512 samples, 1024 samples. So audio is being rendered in chunks at a time. So that's our second obstacle. So the audio engine is only going to process requests. Like when we just say play, that's not actually going to start rendering. That sound's not going to start being sent to the operating system until it hits the top of the next buffer being rendered. So that's a problem. So we can look back at our timeline here. So if our buffer size is 2048 and our sample rate is 44.1 kilohertz CD quality, then the audio engine is actually ticking every 46 milliseconds and change. So now it looks like this, which is rough. Now we have two grids here that we don't like and have nothing to do with our goals. So we might see here in frame 5, it might be our blueprint's turn to update and say, ooh, it's time to play a sound. And we'll play a sound. It'll get over here to the audio engine and it'll say, sorry, I just started rendering another buffer. I've already processed all my pending requests, so you'll have to wait. And so our sound won't actually start until the beginning of this next buffer, this next update. So here in gray is our expected when a 16th note should have started, and in blue is the actual onset that we're experiencing. It's not as bad here as it is here, but the fact that they're different is almost a big part of the problem. Like we could deal with just latency is a lot easier, but we're having jitter, right? This error is variable. It's not always the same every time. So core issue here with playing sounds on a strong boundary is that we're being quantized to these two arbitrary grids, basically, our gameplay frame rate and our audio engine update rate. And that, again, sucks. So this is the same video from earlier, but now that you have this mental model for we're being snapped to two grids we don't care about, and the delta between when we wanted the sound to play and when it actually plays bounces around. It's variable. You hear the same thing back with the 16th notes again, A, B. Cool. Does that make sense? Good. Any questions? So this arbitrary and inconsistent quantization is part of what Quartz solves, at least the part of getting a sound to come out of the speakers when we want that sound to come out of the speakers. So how does it do this? Well, at its core, Quartz is a scheduler. So the flow we'll see is you can create and control clocks from the game thread. Those clocks live on the audio engine, but you have clock handles that we can use to schedule sounds on them with play quantize, like we saw earlier, as well as do things like change BPM, that kind of thing. And then it also lets you sync your game visuals with audio. So game logic can piggyback off of these audio events. It can basically be told by the audio engine what's going on so that you can have visual elements, whether it's VFX or even game logic, like you can't jump until the downbeat. I don't know, that'd probably feel horrible, but as an example. So this is like a hello world blueprint of what using Quartz is like. So starting from the top left, this is basically like the top row is the stuff we would do once, right, and begin play. So we're going to get the Quartz subsystem, and we would create new clock, and we're going to give it a name. I'm calling it main clock. And that name is important because any other blueprint actor can just tap into it, right? Anything else going on in the game at any point in space can say, I would also like to care about that because I'd like to bounce up and down on eighth notes or whatever. So this is a nice way of sharing it around, is to just use names instead of any type of hard reference or anything like that. And so we'll initialize this clock with some settings here in the make Quartz clock settings. So for now, we're just giving it a time signature of 4/4. The set call here to the right of create new clock is us setting this as a blueprint variable. We're holding on to a reference to it, so that we can use it later, and B, because Unreal Engine is garbage collected. So if we don't hold a reference to this clock handle, it's just going to go away. It's like the #1 question I answer on the internet is like, I got my metronome going, and then like 8 seconds later, it just stops because they never held a reference to it. Then we can set, now that it exists, we can set our beats per minute, which we'll do 120. And then we're doing something here. We're subscribing to all quantization events. So this is what I was using earlier, right? And I said this was Quartz. We are saying, hey, you have that clock that's running, that's great. I'm going to play sounds on it. But I would like Quartz to tell me about these musical durations. And so you can, there's a flavor of this, which you can just subscribe to one thing, bar, a beat, dotted eighth note, whatever. Or the one I'm using here is I just want to subscribe to everything. I want to know about it. So then this event is what will get called or will fire for every musical duration we have, whether it's a bar, a beat, eighth note, whatever. And we can just tap into the ones we care about and call play quantized. So I can't remember if this is a video. No, it's not. So this is the backbone of that metronome event we've heard, or metronome example we've heard a few times now, right? We create a clock, set a BPM, say, hey, clock, please tell us about the musical durations, and then start running the clock. And then in here, this will just fire itself as we get notified about things going on. So every bar, I say, great, thanks for telling me about this bar. I'm going to schedule a sound to play on the next bar, right? And same thing for every beat and every eighth note. So how does it actually do this? If we look back at our timeline, how does play quantize overcome the issue of these arbitrary grids that we normally be dealing with? So here's an example. At the top of frame 2, we're going to schedule this last 16th note to play. We're going to say, hey, 3 16th notes from now or whatever, I want you to play a sound. And so that gets to the audio engine here, right? It gets to the audio engine here, but it's not going to get processed until the beginning of the audio engine's next update. And so the audio engine sees it on its next update and says, okay, good, you let me know plenty early, we can do that for you. And so it does the math. It says, based on this musical deadline you've given me, it's going to be 9,339 audio frames until this sound should actually come out of the speakers. So it's not time to play yet because my buffer size is 2048. 2048 is less than 9,000 whatever. So I'm just going to hold on to this. And the next audio engine update, it's going to subtract. It's going to say, well, I'm about to render 2,048 frames. So the new deadline is 7,291. Still bigger than 2048. So I'm just going to keep doing what I'm doing. So it keeps doing that. Every update, it holds on to that request, subtracts the number of frames we're about to render until the number of frames left on this deadline is less than our buffer size. So it says, okay, it's time. This next buffer needs to have this sound in it. And not just at the top of the buffer, like every other sound we play in the engine, but we want it to start 1,147 audio frames into the buffer, so mid-buffer. So what you don't want to do in audio and a lot of things, we have a lot of optimizations around the amount of work we're about to do in a buffer, which is why changing your buffer size in a DAW has such a big impact, right? That trade-off is lower buffer size is lower latency, but higher CPU usage. So the sound designers have chosen a buffer size for this game to run at, or the user has, depending on their sound card. But we don't want to all of a sudden say, hey, Quartz is here. We're going to just ignore that and do like a partial update and then redo all that work again and do another partial update just so that we can play a sound mid-buffer, right? So the easier way to do that is to we just run it through a delay line. So we play it like any normal sound, but we run that particular sound through a delay line set to 1,147 frames. So now, because we've done all this, our expected onset and our actual onset are the same exact sample. It's sample accurate. Does that make sense to everybody? Any questions on that? This is probably the headiest part of the presentation. But this is how play quantize works. If you schedule ahead, if you give the audio engine enough lead time, which can actually be pretty small, a lot of people have systems running, scheduling things in eighth note in advance or whatever. This is how we actually get a sound to come out right on our musical grid, ignoring frame rate, anything else. And you can actually, you can get nuts and just schedule like 1,000 events to happen between 2 video frames. You could have a sound, I want a sound to play every millisecond, and it would do that for you because it's totally independent of the actual frame rate that you're running at. Okay. So this is that example we were talking about. This is all Quartz now. This is our hello world. We create a clock, set the beats per minute, all that stuff. You don't have to see the text on the screen, but you can just see the flow of execution in our metronome example here. That was longer than I remember making it. So that's how that's working under the hood, right? Sounds nice and locked in compared to those earlier examples. So cool. Now let's start talking about how we're going to get the game to respond to this. It's one thing to be able to play things and have them come out the speakers at the right time, but we also want to be able to have, things we see are what creates things we hear. So how do we get these systems working together? One we've already been talking about, which is the metronome events, where you can just get notified, and that's how I was having all the blocks bounce every beat, was with the metronome event. But you can get a little fancier, and you can use this thing called a Quartz notify, which is where the same object we use to describe a deadline, called the quantization boundary, when we would say play a sound in 2 bars from now, or in the next multiple of 4 bars in our song, right? Or in the third beat of a bar. Any of this stuff is represented by this object here. So now we can use this for Quartz notify and just say, hey, let me know about just let me know once about the next time this thing happens. So in this case, it's the third beat of a bar, if you can see up here. It's quantization's on a beat, the multiple of 3, and our counting reference point is bar relative. So it's going to be on beat 3 out of 4 of a 4/4 bar. We're going to get this notification is going to fire. All right. So it's only going to fire once by default. So we get that and we say, okay, if it's started, then I'm going to flip the material. So in this next example, you'll see this cube here is going to flip materials on beat 3 of each bar. So it's kind of a more nuanced thing than just a metronome event. But then once we do the part where we flip back and forth between what the cube looks like, we're going to say, all right, thank you, I've done my work, go ahead and notify me again. So you see how we get it going here, but then after each notification we get and we do the work we wanted to do, we just hit that, we execute that function again, saying, let me know about the next one. So it becomes kind of a feedback loop that we'll see here. So same blueprint, you'll see it execute, and you'll see this flip material on beat 3 of each bar. One, 2, 3, 4. Cool. So now the audio engine can notify game logic of musical events, and we have a couple tools at our disposal to do that. So that's rad. Now we're excited. Now we're saying, great, we have this system. Let's go get the visual effects artist to do something cool, which would be great. And so you go knock on the visual effects artist's door and you bring them their coffee and you say, we got this thing where we can be told about dotted eighth notes and you can do some sparkles or something, and it's going to be an awesome collaboration. The VFX artist says, what is a dotted eighth note? So you run into this type of situation where the VFX artist does not know what you're talking about. But what they do like is curves. They love to animate things, right? If they're going to bring something to life. So that was the next complaint I kind of got, or the next request is, these notifications are cool if you know about musical durations and all that stuff, but when we're bringing in the big guns to make some eye candy, that's not what they're looking for, right? So we give them what they're looking for. So in addition to metronome events, notify events, now we have get beat progress percent, which is naming things is hard. I don't know what you call this, but this is a node or Quartz feature that you give it a musical duration, like a bar, and then every tick, it'll say, hey, you're halfway through this beat. You're 3/4 of the way through this beat, right? And so this is handy. Now we can have some arbitrary curve and between 0 and 1. So in this case, we're going to, what are we doing here? Whatever our actor is, we're going to move it up and down based on how far we are in the into the beat. So this is those those spheres in the initial demo bouncing up and down on the beat. And this is great because this animation will work even if we change the tempo, anything like that, it will just respond, right? So in this case, we're gonna go up a bit, a quarter of the way through the beat, and back down to 0, and then dip below in the last 3/4 of the beat, and come back around. So here is a video of not that, but this is this is a video of you can see this curve being edited in real time, and it changing this sphere here. So the red line on this curve that you see in the bottom left will be the light it emits. The blue line on this curve will be the vertical scale, and the green line is the horizontal. So that's cool. That's looking cooler than our just like change material on the third beat of every bar. And now the VFX artists are happy. They can go make some curves, and everybody's happy. But there's still one more. There's two more hurdles, but there's one big issue with this, and that is at large buffer sizes, audio buffer sizes, the audio engine's update rate can become the limiting factor, right? It can be slower than the game's frame rate. So now we have kind of the opposite problem. So the game is expecting a nice smooth ramp, right? As we go from 0% of the way to our beat back up to 99% of the way back to our beat. But if your game's running at 120 hertz and your audio engine is going real slow, like if you have a big buffer size, then we become the limiting factor, and we're going to start giving the game multiple game frames the same value. So it's not going to look smooth. So here's what that looks like. So if we're at a buffer size of 4096, our audio engine is going to update like how far we are through a beat. All this logic is going to update at 92 milliseconds, which is massive. So what we want here, if we're talking about quarter notes is the thing we want to drive a curve with, then what we want is this nice ramp. Starts at 0, goes up to 1, and then snaps back down to 0, goes up to 1 again for the next quarter note. That's what we want. But we have this huge, slow audio engine update. That's a problem. So these are the values we're actually going to get from our game. So the first frame is going to get a value. Everybody's happy. Second frame, the game's going to get the same value and say, okay, that's weird. Third frame is going to get the same value. The game's going, come on, man. Like everybody else optimizes stuff to run this game at 120 hertz, and now your thing is going to look all chunky coming through. So what we have to do to solve this is just extrapolate, basically. So Quartz will take the last 2 updates it had, as well as the wall clock times that did those updates, and it'll say, okay, I was here at this time, I was here at this time, and now on frame 5, the game is asking me where we're at, and so I'm just going to say, draw a line here and say, I'm just going to lie. I'm going to, instead of whatever my last update was, I'm going to say, we're probably about here now, right? And so we'll get this smooth extrapolated line instead of taking the audio engine's updated values at face value. So this isn't the best video. I defined this in my Slack because this is a video I took when I was solving this problem. If this is hard to, if the green cubes are hard to see, you can watch the shadows on the ground. But this is me. I had hacked some code in to turn on and off this extrapolation. So this is a video running at 60 hertz and with an audio engine block size of 4096. So the audio engine's updating every 92 milliseconds. And it's when I start playing this, it's not going to look like it's running at 60 hertz. These cubes are going to look real chunky. And then you'll see me toggle it on, and this will say it is extrapolated, and this will now look smooth. So you can see what it looks like when you have not solved this and when you have. So it can be pretty gnarly at slow audio engine updates. But you still tell all the other disciplines that we run at 48,000 samples per second, not 92 millisecond updates. And the last obstacle here, which is kind of someone might have picked up on, it's a bit of an issue throughout Quartz, so I don't have a specific demo for it. But light travels faster than sound, and so we've just spent the last 45 minutes talking about how our audio engine is going to tell the light engine what to do. You can see how that might be a problem, right? Because out in the world, since sound is slower than light, like if someone bounces a basketball, the sound is always going to arrive to me later than the visual stimulus, right? And so, and human tolerance reflects this. So we are pretty error tolerant when you're talking about audio-visual sync, as long as the sound is coming after. It looks like the thing creating light is also the thing causing sound. But we are not very tolerant the other way. Like if you ever have your Netflix stream get a little bit out of sync, and all of a sudden the dialogue is playing even just a little bit before you're seeing the lips move, your brain's like, this is bad. I've never seen this before. Alarm bells. I do not like it. And we want people to like it when they play our games. So Quartz has a couple mitigations for this. A lot of like the notify, Quartz notify, and the curve look up the beat progress thing. Both have offsets that you can add just to dial in so that the game is getting notified a little bit early, as well as like any play quantized, any quantized command that you can send with Quartz, including play quantized or changing the BPM at the beginning of a bar. You can respond to the different phases, like, okay, hey, your command got canceled, or your command has made it to the audio engine, or your command is about to start, or your command has started. So that has started means literally the audio engine has started rendering your sound or whatever. But about to start is using this heuristic of latency for inter-thread communication to try to give the game a little bit of a heads up, like you should do your thing now if you want to look like you're the thing that caused the sound. So this is the same ball being animated, but this towards the end of this video, you'll see me dial in the phase offset so that the visuals look like they're preceding sound. And it's not super perceptible, especially something as intangible as a glowing disembodied ball floating in the sky. But the thing I want you to look at when you're watching this video and also listening to it is it should start to feel snappy. It should start to feel like the ball moving is the thing that's creating the kick drum sound. So towards the beginning, it would feel a little bit detached by comparison, and then towards the end, hopefully it'll read that the visual curve is preceding the sound enough to really feel like this object is what is making the sound. It's also in 7/8 now for fun, because Quartz can do compound meters. All right, so so those are the individual elements at play. That's kind of an overview of what Quartz is, why it exists, the problems it solves. And so here's this original shorter version of that first demo I showed you of me doing Quartz to the first-person shooter template. And then this is also, again, just in 7/8 for fun. I didn't have to change anything about my implementation to change time signature other than the level blueprint. Literally just instead of saying 4/4 when I created the clock, I said 7/8, and I gave it my list of where I wanted beats to be. In this case, two quarters and a dotted quarter. So it's 1 2 1 2 1 2 3 1 2 1 2 1 2 3. That's the only thing I changed. So in summary, we talked a bit about games, game engines, audio engines, how there's multiple threads, things are happening at the same time, but the game is engine's talking to the audio engine, and it's not all real time. It's very discrete update intervals that don't line up, and this causes issues when you're trying to play sound on a nice grid, because there's two grids working together to make your life horrible in that endeavor. Talked about how Quartz sidesteps these issues to let you schedule ahead, and it'll do that tracking for you. And then we looked at some way Quartz lets you communicate audio state, basically musical state, back to gameplay and visual effects logic in a couple different ways that are basically just convenience wrappers. Any questions about that so far? Cool. So I want to leave you with a little Quartz sizzle reel of things that are out in the wild. And these all play back to back. So the first thing is this Fortnite infinite downtime music. There's a couple of Fortnite updates where we've actually turned the game off for a while, but between big chapter updates. One of those times, and so when you would log in, you'd see something different. The first time it was like this swirling black hole making some cool synth sound. It was just that for like a day or two. The second time they did this infinite downtime music, which is we hired someone to make a bunch of music stems, which are just using Quartz to procedurally stitch them together. And so it was this over 10 hours of kind of this like chill step lo-fi music with also using Quartz events to pulsate these fauna, which is cool. And then the second thing, Deadmau5 is actually a pretty big fan of Quartz, and so I talked to him a lot on Discord, as like tech support and the stuff that he's doing. And so I told him, I said, hey, I'm doing this talk. Is there anything you want me to like plug or show of the stuff that you're playing with? And within 30 seconds, he sent me this thing of like cats and chickens bobbing their heads. So you'll see that. I had to see it. You'll see it. And then the third thing, Mixed Universe, is this game Chris Zuko released last year, I believe, which is this huge sandbox of where you get to make your own songs and schedule things, and uses Quartz heavily, Metasounds heavily. There's a ton of eye candy going on. It's awesome. You're literally flying around through this huge songscape you've created. And then the last part of the video is the game Blaster Beat, which is like a rhythm shooter that came out also Quartz driven. So I'll play that for you. This was also all copyright free for streamers because we had all the rights to the stems and it was just stitched together at runtime. Thank you for listening to my talk. Happy to take any questions or circle back to anything, if there are any.
I have a question right away. You mentioned that some of that was rights free, so copyright free. Are we going to I put these on YouTube, these recordings of these videos. Am I going to get any notices from?
The first demo, yeah, you'll be fine.
Say again?
The first demo, you'll be fine. The glowing mushrooms, that's copyright free.
Okay.
Is this a serious question?
That's a serious
Oh,
question.
yeah, no,
yes.
you're fine. So even the
For
other
this
stuff, sorry.
entire, this entire record.
No, that's all fine. This is all stuff we've already had cleared and has been in other sizzle reels and stuff like that that we have on YouTube already.
Okay, but
So,
there's bots that come and
Yeah.
grab stuff, so it'll be fine, huh?
Mhm.
Okay, great, thank you. Turn it on, please.
Hey, hi.
Hey.
I'm in audio, so I know how to turn the mic on. So you were talking about filling buffers, and you only ever talked about one buffer, but like normally there's multiple buffers trying to be filled.
Are you talking about multiple buffers, like you'll stage multiple buffers ahead to be consumed by the operating system, or are you
Yes.
talking about source audio? Yeah.
So I was wondering, like if I tell the audio engine, I want you to try and fill 4 buffers, is it always going to fill 4 buffers? Is it going to do a max of 4 buffers? Like, how does that work?
For Unreal, you can set a limit to how many buffers it gets ahead of what's consumed, basically. So, and that's kind of orthogonal to Quartz, but you'll say in your sample rate and next to your like buffer size, you can say the number of buffers it'll render. And if you say to set it to 2 or something, and if it goes to do another render pass and those 2 are still sitting there and haven't been pulled off by the operating system, it will wait until. And those are all rendered serially too, so that it all works nice with this state that we're talking about with the scheduling. Yeah.
Hey, Max.
Hey.
So the Quartz system seems pretty detached in terms of its buffer and its scheduling, very much different from the game loop.
Mm-hmm.
How does variable refresh rates affect the Quartz system? Things like vsync, FreeSync, G-sync,
Yeah.
stuff like that.
It really doesn't, and I'll give you a caveat, but because as long as you can give the audio engine enough of a heads up, as soon as you say play quantized, that is something that happens during a visual frame update, right? As long as you get that out the door in time, nothing else that happens on the game thread matters in terms of other frames taking different amount of time, right? So the one thing you will run into is, say your frame rate is so low, or it might dip so low because you're on some handheld platform from 2 decades ago, that you don't even have the time to call play quantized in time. Does that make, you could see that as being an issue, but you can just have a system that says, okay, I'm missing some of my gunshots just because they're not making it in time. I literally am not getting enough updates to call play quantized frequently enough. You can just call it twice. You say, I want to play one on this 16th note, one on the next 16th note, and I want to get notifications about those events. So every time one hits the audio engine, I'll just queue up another one. So you can make it tolerant to really big game frames by just scheduling it ahead. Dan Reynolds, our technical sound designer, actually has a video where he's literally just like scheduling hundreds of gunshot sounds between gameplay frames. So as long as you give yourself enough runway, you're totally decoupled from the gameplay frame rate.
Awesome, thanks.
No problem. Cool. Are you good? All right. Thank you, everybody.
All right, thanks, Max. Wonderful presentation. Let's have people start in the room here. Come up to the mic and please tell us your name and what's your audio. Well, yeah, I guess we could do that. Let's do that. We'll pass it around. Well, no, because we want to get you on camera. So come on up here, please. Steve, start.
Hi, I'm Steve Turnage, mastering engineer, circuit board designer, sometime author, sometime musician. Play with him occasionally, play with him occasionally.
Kai?
Kai Esbenson. I'm nobody. Friends with Steve.
Okay. Next, please.
Let's line up. Come on, let's get going, guys. You already know me. I'm Lawrence Schwedler. I'm the program director here at Digipen of the music and sound programs, and I'm also the treasurer of the AES PNW section. Woohoo!
Howdy, I'm Noah Lodoff. I'm a alumni here from the Digipen Music and Sound Design program. Worked on Halo Infinite, Lego Fortnite, other projects that I can't talk about.
Yeah, my name is Jonathan Larson. I am a current student here studying music and sound design at Digipen. Yeah, I thought this was a really interesting talk. I kind of geek out about the technical side of stuff too. I almost applied for a CSDA, but decided I didn't like math enough. So.
Hello, I am Blake. I am a sophomore BMSD. Similar comments to Jonathan. Very exciting stuff. Thank you.
Hi, my name is Blake. My name is actually Blake. I'm a freshman BA MSD, and I also enjoy audio programming of it. Yes.
Hey, I'm Austin Clark. I am a third-year student here at Digipen in the CSDA program.
I'm Max Van Ginneken, and I'm a senior BA MSD. And I want to thank you, Max, for letting us bounce some questions off of you for the game project that I was working on last term.
I'm August McCubbin. I'm the Sound Lab manager here at Digipen.
Amanda, I'm a senior in the Computer Science Digital Audio degree program.
My name is David Shannon, and I'm building a live music metaverse.
I'm Ian Shores, 12th year student here at Digipen. Just kidding, I'm an alumni.
I'm Caleb Klomfarens, Associate Software Engineer at Highware Games, and I just renewed my AES membership.
I'm Cody Melvin. I'm a second year here, not in any audio degree. I just thought this would be interesting.
Oh my gosh. Hi, I'm Shawnee Zhang. I'm a senior audio designer at Microsoft. I'm also an alumni here from BMSD. And I also renewed my AES membership last month.
Hi, I'm James. I'm a sophomore BA MSD here at Digipen. I'm very excited about this kind of stuff because I really like audio programming and stuff like that, and adaptive music as well. It's pretty cool stuff. Thank you.
Hi, my name is Avery Steinis. I'm also a sophomore BA MSD at Digipen. Thrilled by this presentation. It's really fascinating stuff.
Hello, I'm Race Roberson. I'm the physics department chair here at Digipen, and so I teach some of the classes and the programs that he's set up, and want to try to get more of the education to help direct very much the postgraduate, getting you the tools that you need to do the work for all the students here, hopefully. Fingers crossed.
Hi, I'm Alistair Hurst. I do game developer relations at Dolby. I'm on the advisory board here at Digipen, and before that was 29 years doing game audio.
Hey Max, I'm Jake, also a Digipen alumni, was a BA GD here studying game design, and I am a senior gameplay designer at Midwinter Entertainment here in Bellevue, Washington. A behavior interactive company. They make Dead by Daylight, and I work in Unreal Engine, and yeah, and work with the audio team there, and I'm passionate about sound and super cool stuff, Max.
Hi, I'm Al Farrow, and I work with Max at Epic. Yeah. Yes, that's who. I also graduated from Digipen like 2 years ago.
I'm Gary Louie. I'm the secretary of the Pacific Northwest AES section and an AES Life member.
I'm Caleb Kingsford. I'm a senior computer science digital audio student here at Digipen as well.
Great, thank you. Did we get everybody? This is your last chance here before we go online. Okay, I'm going to call on people who are online, and please unmute yourself and turn your camera on and tell us what your audio connection is and where you are. Let's start with Han, H-A-N. Can you, oh, you don't have a microphone, shoot. Type into the chat, please, if you don't have a microphone, and I will read it for you. So Trevor Richardson, where are you? I think we know that from looking here, but tell us anyway. And what's your audio connection?
Yes, I'm in Seattle, Washington, in West Seattle, and I'm a sound designer at a sound and music design company called Sanctus. And yeah, I've been there for a long time and did an audio engineering degree at Belmont University in Nashville, Tennessee.
Cool, thanks for joining us. Trevor Richardson, where are you? What's your, oh, sorry, I just read that. Rick Chin, where are you? What's your audio deal?
Hi, I'm in Sammamish, Washington, which is across the street, across the lake from Microsoft. I'm the webmaster of the AES section here and a life member.
Okay, and Han wrote in that Han doesn't have a mic, but if you type in where you are and what your audio thing is, I will read it for you. Min Jung Kim, where are you and what's your audio deal? If you're able to unmute yourself, please do so. Oh, you wrote, hello, Han and Jion and Hyongsong Shell. We are technical sound designers and audio programmers of NC Soft. Sorry, we don't have microphones. Where are you? Are you the guys who signed up from Korea? South Korea, yes. All right, welcome. Thank you. What time is it there? They said, yep, that's 12:40 p.m. Well, that's tolerable. Gee, well, thank you for joining us. It's a pleasure to have you with us. Maggie Tobin, can you unmute yourself and turn your mic on and tell us where you are and what your audio deal is?
Yeah. Hi, everyone. I'm Maggie. I'm a content creation specialist in the sound research lab at Dolby. I specialize in Dolby Atmos mixing, and I'm based in San Francisco. But just kind of jumping into Unreal Engine. So thank you for the really interesting presentation. It was really great.
Great. Thanks for being here with us. Mac Perkins, you know the drill?
Hi, I'm Mac Perkins. I'm in Whidbey Island, Washington, about 20 miles north of Seattle, and done a lot of things from broadcast, theater sound design, system installation, you name it. And this is an interesting introduction to an area that I'm extremely unfamiliar with.
Cool.
Thank you.
Thanks for being with us. And I'll note that Myun Jung and Han said thank you for the great session and thank you for the event. Nice going, Max. Maggie Tobin, did I already do you? Yes, Jasmine Lau, please tell us where you are and what your audio deal is.
Hi, I'm Jasmine. I'm a sophomore student at Digipen, and this has been a very exciting talk, so thank you for having me.
Thank you for joining us. Gary Gottlieb, the president-elect of the Audio Engineering Society. Where are you and what?
You blew my punchline for me. Oh, well. Yeah, I'm an AES Fellow. I live in beautiful Ukiah, California, the county seat of Mendocino County, where I teach at Mendocino College currently. Former longtime engineer, producer, went into education. One of my many duties at AES is running the conference committee and the events coordination committee. And I am happy to say that there's going to be a conference on audio for games later this month in Tokyo, which I'm grateful to be attending. And this was such a great warm up for that. Also, while I'm talking about conferences, I have to put a plug in. Lawrence was so gracious to host the AVAR conference once again in August. And I know those of you at Digipen are very excited about that too, or at least I hope you are. And thank you for a great presentation. Always, I always count on PNW for the best presentations. So thank you.
Thanks, Gary. Thanks for joining us. Dave Quick, where are you and how's your studio doing?
I'm in Port Townsend, Port Hadlock, Washington's hub. Washington.
You got it.
And I I oh, um uh um um I'll uh 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 um uh uh oh
How is your studio?
That's what I'm trying to tell you.
Oh, good.
Uh, uh, um, uh, so, um, uh, um, just finished the console.
Cool.
Yeah.
Is that it behind you?
No.
Oh, okay. I see a patch panel.
Yeah. Um, uh, um, yeah.
Okay. It's great to see you always.
Yeah.
Thank you. Jess Berg, where are you and what's your audio story?
Thanks. Yeah. So currently in St. Paul, Minnesota, formerly of the Pacific Northwest and Los Angeles area. I am a current AES member and a committee member of the section, and I'm thrilled to be able to participate from afar. I come from a live sound background. I was a touring live sound engineer, tour manager, production manager, mostly front of house, some monitors. After COVID, I've been recruited and now working in broadcast audio. So, yeah, that's what I'm up to, and really glad to be here and just happy to be a part of it. So, thank you.
Thank you, Jess, and thanks for your work on these. Let's go to Ben Steele. Where are you and what's your audio story?
I'm in Olalla, Washington. I'm going to retire from the Army in about 6 months or so. And then I'm a hobbyist musician, and my family and I are moving to Nashville area, and I'm going to study studio engineering over at Blackbird. And I've been an associate member of AES since January.
Cool. Thank you for joining and thanks for being with us. Janie, where are you and what's your audio deal?
I'm Janie Wallach. I'm in Seattle, Washington. I record live audio, including this weekend, if anybody's interested. I'm doing part 2 of a festival that started last weekend and concludes this weekend. So if anybody wants to come on down, just chat with me privately.
Okay, did we miss anybody? Now's your chance. All right, so we're going to split up here. Gary put in the chat about the conferences. Okay, there's a variety of upcoming conferences. So we're going to split up here, and Janie, I think, is going to continue the conversation online. And here in person, we can get some cookies and water and chat amongst yourselves. So thank you, everybody, for coming to our meeting.